Okay, guys. So, I welcome you to my presentation about the GNU Radio runtime, and the subtitle is Reinventing a Very Fast Wheel. So, Derek asked a question: who doesn't know GNU Radio? I think there were a couple of people who never used it. This will be pretty specific to GNU Radio, but it may also apply to other digital signal processing frameworks. So, yeah, my name is Andre Rode. I will introduce myself right now. I will first talk about the actual state of the GNU Radio runtime. So for the upcoming release of GNU Radio 3.8, what are new features, or are there any? Also, I will talk about the GNU Radio runtime in the retrospective. So what features did we, or did the previous developers add to the runtime, and how did that come out in the end? And also then the new stuff, so future of the GNU Radio runtime. So I talked with at least Marcus and Basti, so we had some thoughts and what can we do to improve the whole situation, to make things faster, or to improve on other optimization goals. So I'm actually a EE student at the Karlsruhe Institute of Technology. My primary focus is on DSP and also communication engineering. I also currently run the GNU Radio CI, so the little billboard thing that is building all the pull request stuff, and also I'm herding the web infrastructure, so you can see nice things on the website. I started using and contributing to GNU Radio very recently, so 2016 is just about 2 years ago, so I'm pretty young in that respect. But I have a great interest and will hopefully contribute more and more to the radio infrastructure, and I also have fun with SDR sometimes, so So what's the current state? So for the upcoming 3.8 release, the runtime does not contain a super new shiny feature we want to push people to use. It contains a lot of dependency bumps. So the whole GNU Radio project is now porting to Qt5 and Python 3 and GTK 3, and a lot of stuff is going on, but no real shiny feature. And this raises the question, are we yet done? So is this whole runtime scheduling thing done and we can now focus on only doing DSP from now on? And unfortunately, this doesn't mean we can stop developing the runtime and scheduler and stop improving, basically. We have to improve it. And GNU Radio is a piece of software basically electrical engineers and communication engineers and DSP engineers are attracted to. So most of the time people work on what they like to do, and that's DSP stuff. Runtime is it's more computer sciencey, so you have to do scheduling, you have to do buffer passing or buffer handling, and that's a necessary evil, but you have to do it to get your samples around. So, how did we come to the current state? So I have gone through the Git history to see when new features in the runtime came in. So basically, GNU Radio started out as a simple sample processing framework. So you put in data on the one side, you get data out on the other side without other stuff messing with it. And then 2000, and it was single-threaded, so it was okay at that time for the goal Eric and other people had to solve. So just in 2008, a multi-threaded scheduler, the thread per block scheduler, was added to the core. Then also message passing was merged. So message passing is something entirely different compared to the simple streaming. So you're not just continuously streaming samples. You want to basically have packetized data, or not back pressure your data. Then also a very nice feature like the tagging capability was merged, so you can now add metadata to your samples, like which frequency, amplitude, not amplitude, but frequency, other phase offsets you measured to correct for them. So it was a nice thing. Then also control port. So this was added to like introspect the flow graph, to have like also performance counters to see which blocks are performing well, which blocks are like holding up the full processing. Yeah. So it continued, and like for the next release, the single-threaded scheduler is thrown out, so it's already merged in Next. So there won't be a single-threaded scheduler. So we are left with a thread per block scheduler now, which is doing a very good job, but there might be some improvements still. So achievements, right? GNU Radio is like the biggest open source DSP project used. Today we had like 4 or 5 projects using it, and it's really good at what it's doing right now. So the back pressure driven architecture is great. You can do the sample processing without hassle. You only have to focus on your own block, so the simple block API. If you want to write a fur filter, you just focus on what you have to do to filter the samples, not how to pass around data or to get your data from your radio and then somehow manage to catch up. So this is all done by GNU Radio. It's great. Also the strict block boundaries, so blocks are not interfering with each other in terms of concurrency issues or locking or something. If you just do like sample processing, you don't have a problem. And this leads to a lot of new projects, and today we saw some, and there are still hundreds of other projects and companies using GNU Radio. So shortcomings. One thing you might notice when you run like a large flow graph with a lot of sample processing blocks is cache invalidation. So you have like say 100 blocks doing stuff, and then the thread per block scheduler, he will spawn a thread for each block, and then calling the work functions of each block, the GNU Radio basically hands off the hard work to the OS, and the OS is then taking the threads and schedules them on cores and on hyper threads, and is passing memory around and arranging everything, which is, the OS is good at that, but the OS doesn't have like the information. How does your flow graph look like? Does it make sense to like keep like one stream on one thread or one CPU to use the cache and not like invalidate your cache all the time, and then to have to move around between different CPU blocks. Also, we have a lack of tests for core features. So if people like submit bug reports and fixes for them for core features like tags or message passing or something, it's not always clear if that only fixes that bug or if it also opens up a new path of bugs coming in. So that's a bad thing. Also, the runtime API is sometimes a little hidden. So you can use just the normal features and you will be fine. You won't run into issues. But if you start like using extensive hidden features basically, and then we remove them or we update them or something happens, your blocks break. And one of the resolutions later will be we want to add like first the API and then like implement it, so we have a clear line where to go. This probably resulted in just the organic grown code. So you saw the timeline here. So it's like 8 to 9 years just for these features, but the development started earlier. So like 10 years of code. It's quite natural to have like some organic structures and missing docs. So we also have a lot of lacking thread safety for direct method calls. So if you have like your flow graph in Python, you can actually call into blocks and trigger and call functions, but most of them are not really thread safe, and we have no real means to protect that right now. And also we have a lot of varying code quality, so a lot of contributors over the years contributed different parts, so that's also quite natural. So for the varying code quality, I just like plotted a coverage statistics. So in the top we have the DSP things like GR filter and GR analog, which are very good tested quite well. So about 80% of the code lines run during tests, and then somewhere in between you have the runtime, which is sometimes tested by accident because it also gets run when you run anything in GNU Radio, but there are also actually tests in the runtime, but it's about 60% here. And then we have like a whole lot of blocks which is not runtime related, but in the GNU Radio project which are like not tested at all during our normal CI tests. So people encounter bugs and they report them, but that's, yeah. Then some other shortcomings people encounter and also solve in their own project is like the integration with other heterogeneous computing. Like if I don't only have like one CPU, I want to use GPU, I want to use an FPGA or other DSP coprocessors. There's no way of handling these custom DMA buffers in GNU Radio. So people come up with solutions. At least for the GPU side, there are at least 2 or 3 projects who implemented OpenCL and even had buffer passing between blocks. Since the runtime doesn't know anything about this, was like finger crossing. I just pass between one GPU and then keep my data on it so I can use the maximum performance. But also like cloud or say remote computing, I want to hand off. So I want to run a flow graph and I want to hand off certain parts to other instances of my like AVI's cluster or something. This is pretty hard to do in GNU Radio right now. So you have to, you can, for example, use 0MQ and then have one end implemented and then like run another flow graph on the other side, and then you have to manually make sure to everything runs at the same time and is passing the data correctly. Also, issue is like low latency applications. This is also a lot of work was done by Bastian Blössel for the Wi-Fi stuff, and basically he had he also looked into other applications or frameworks, and there was this Microsoft Sora, which already implemented this like 10 years ago. And there are also other issues with the current implementation. I skip a little bit to what we thought of for the future of the GNU Radio runtime. So first I want to compare to other similar projects. So I already mentioned Microsoft Sora. What we mean to design and what's the timeline for this, for our thoughts. So first question is, do we need to improve the runtime itself at all? Can't we use just already implemented processing frameworks or other computation frameworks to do the job, even in other signal processing frameworks maybe? So we have, I did, it's not a finished list, but some projects who are pretty similar to what GNU Radio is doing. So Sora, and there's this SRS LTE, which are pretty application specific. So one is about Wi-Fi, the other one is about LTE, obviously. And also some other stuff, but no other project really matches the goal of GNU Radio to have like this generic processing, and also of the existing ecosystem. So for GNU Radio there is already a big community and a lot of people doing own projects on top of the framework, and basically we think we have to still continue improving the runtime itself and can't just use anything else as of right now. So what are the challenges that are not solved currently? So I did like a list of shortcomings. So those are the things we think need to improve and to continue, to provide GNU Radio with a path forward for like new other developments in this regard. And yeah, what should an API look like? So that's where like all of you come in also to give us more hints or like tell us what you want to see, what's the current problems or struggling with the runtime. We see some projects, not all of them are open source, of course. Some are like hidden between, hidden in company walls. What do we, yeah. And also, how can we keep stuff around without reinventing the wheel, like Ms. Light said? We don't have like answers for all of these questions, so we're still in the process of working stuff out. And first thing is design theory. So there is already a thing called like concurrent computing. So that it's describing what GNU Radio is doing if we leave out all the digital signal processing and the radio related stuff. Basically what we try to solve is concurrent computing. And there's quite some ways to describe this from an academic's point of view. So there's like the actor model is a word. There are, for example, Petri nets or other process calculi they are called. So we can come up with something that matches what GNU Radio is doing and try to apply that. And also the design goals in the end, they vary because you can optimize for latency. That means in a practical sense you have to squeeze down your buffer sizes to very small sizes. Or you want to optimize for throughput. For example, with a GPU, you need a couple of thousand samples to do like real processing. Okay, so our design goals are obviously API before implementation. So we are now in the process of designing and coming up with a good API for people to use in their own projects and also throughout the GNU Radio tree. So there are also a lot of blocks there. We want to have configurable scheduling inside the runtime. So that means basically you can optimize with very little effort or with not the extensive knowledge of the runtime for latency, but also can optimize for throughput, not only with buffer sizes, but with other scheduling paradigms. Also include the buffer management. So there was already some work done back in 2013, which didn't come into like the core, unfortunately. Also have some more flow graph introspection, and with that also remote computation. So those two are also pretty close together. If we get better introspection, we can also have more scheduled offload to other blocks and have this cross network communication basically going. And also we want to keep all the nice features we accumulated over time. So we obviously don't want to lose multi-threading. We want to support the synchronous streaming, which is the bread and butter for GNU Radio, and also, yeah, other features we have. So most importantly, we don't want to reinvent the wheel. We want to continue with what GNU Radio has accomplished, and also we want to foster other FOSS projects' work to keep the maintenance low. So we don't want to implement everything ourselves. So using existing libraries for example, there's an C++ library for the actor model, which we might or might not use to implement the scheduler, or other projects implementing cross-network communications, and yeah, a lot of things to look at. And yeah, we are actually, right now we're at the step writing down the API. Now, then we want to agree on a technology for implementation and yeah, implement the API. And the last point is basically probably the hardest, is gluing the existing thing together and giving people a path forward to have their out-of-tree modules use the new features and everything we want to provide. So for those things, we also need feedback. So basically you can write me or Markus an email or Bastian and keep the discussion going, or post. I can also probably will post on the Discuss GNU Radio mailing list keep this going. Yeah. If you have any questions about what I told you today, I'm happy to answer or try to answer. I'm also available with the email address or with my nick on Slack or IRC. And yeah, we hope to keep everyone here in the loop and the whole community to move forward. Okay.
We have plenty of time for questions.
Okay, so one of the challenges that we always faced with QA was hardware and non-x86 processors. Do you have plans or thoughts in mind for that? Or
So,
hardware, I mean, like, there's no user attached
yeah, right.
to our CI servers.
So one thing to tackle those problems would be basically writing mock modules or something to mock up the other side. So it should be possible. So other projects are also doing basically mock modules of hardware devices or other databases or something to mock the hardware. This would be a way to improve that. And the other thing was.
So we were doing a lot of ARM development for embedded systems, and we don't really do good QA.
So there's also ways to run like QEMU or something on ARM. I haven't looked into that yet, but this could be a path forward to improve like the support for that and all the differences to x86.
Can I just make a comment? I would say the hardware driver people. That's me. Should be could also help with the mark. Like there should be a way to test UHD without having used something like that. That would be really useful.
Yeah. Other questions?
All right, as you go out, take trash with you and take it as far from here as you can. There's the trash cans filling up. Any more questions?
Yeah, we have time.
Yeah, we have time. I'm just trying to make my life easier later.
I just wait.
Okay, I actually have a question.
Yeah.
So, you said can you do you have a question too? Okay, then can you just go back to because the camera's still running, right? This is the middle of the session. You actually said timeline, but there is no time. Is it because you don't know how much time you'll actually have?
That's the problem, because every one of us three who already thought of that, we all have other things to do and don't get paid full time to work on the runtime and the scheduler. So we have to scramble time to work on that in the free time. Also, there's no real timeline to finish thinking about the things and start implementing. So we need to nail that down pretty soon, probably.
And also, we should use the grep process for a lot of this.
Yeah, but that doesn't it doesn't match too well to the academic kind of research that we will have to do first.
I have to comment on that.